All right, Turbo Pascal mouse shapes. Quickly, this is a mouse shape. It's not the arrow you're accustomed to, and we can basically make them any shape we want. I will show you how. So right here, I have a four-color image. The pink is for the transparent parts of the mouse image. The white and black are the colors, and this light blue is the XOR part of the image. So I'll show you how that works. So if we come back and switch to that image, I have it already defined. So if we compile and run again, so it looks similar, but now if we move over, you can see that the center part changes color depending on what's underneath. All right, so that's all good. And let's just create something from scratch that doesn't normally look like a mouse pointer. So I will clear everything here and let's make a little person. And let's have some eyes closer together and a mouth. All right, that's fine. And if we export and select Turbo Pascal here, and I'm going to call this one M3 just for short. And if we go back into our test program here, so these two, M1 and M2, are the ones I previously drew and demonstrated. I'm going to bring in M3 now, and we can see, I'll go through the program in just a short bit. If we change that to M3, we can see that, hey, we got our little person, and that wasn't very difficult at all. He seems to disappear here. That's because we're drawing him over a white area. Otherwise, it looks nice. So let me go over the code here and show you what I'm doing. I'm going to switch to Visual Studio Code because it's a lot easier to read. Let's reload that so it has. Okay. Let me switch back and just save this. Now we should have a, yep, everything is current now. So these three constant here, M1, M2, and M3, are images stored in a packed format. This is what CGA images uh, are stored as. So if we were to use the put image command on any of these, we can display this. So let me just quickly do that so you can see that that's what they are. So if we do put image here, and let's do it at 80, 80, M3, normal. All right. Okay. So that's the way it works. You can see that it's exactly the same image, but we can use the put image command to display it. I will get rid of that. And what we're doing is using this procedure here, image to mouse shape, to convert that to a usable format that the mouse library can use. And let me switch back to Visual Studio Code. Uh, and it's right here, image to mouse shape. So if we look through this, there's a lot of unpacking of the packed image, and then we use some strings here to create the image for the mouse and the image mask. And if we doing various bit toggles here, 0 and 0 is black, 0 and 1 is white, 1 and 0 is the pink color, which is also transparent, and 1 and 1 makes the underlying image XORed on display, so it changes as you move over it. This is used for like a magnifying glass or some kind of highlighter, basically, if you wanted to highlight certain areas. And we eventually convert this right here. We take the all these bits that are finally formed, and we convert them into decimal using this routine up here, right here. So this changes all the zeros and ones to an actual decimal number. And if we provide that to our mouse routines, the mouse graph cursor routine, we provide the segment and the offset, it allows us to use it as a mouse shape. It all sounds technical, but it's not very difficult. We just have a routine that changes our standard put image to a mouse image. That's all you got to remember. The code is right here. And I've also included the mouse library. I didn't write this myself. This dates back to, is there a date here? This dates back to a long time. You can see the author's name here. I did modify this to work in Super VGA mode as well. So any of the BGI drivers that use Super VGA, this can be used. I'll include this with the GitHub link so you can use this. I chose this when I was looking for a mouse library because this was nicely documented in the code, and I was able to use this. I planned to replace it, but it actually worked so well I've kept it. I've added a few routines here myself. All these I have added. I created a special mouse cursor to work in the 256 color Super VGA mode. And it's all here basically. Anyway, what I want to do next is show you something you probably haven't seen before. And let's switch back to Turbo Pascal. I'm using version 6, by the way, if you're. And so besides exporting the image data from a program like this, you could also grab it off the screen. And I'm going to show you how to do that right now. So I'm going to print the letter N at the top left part of the screen, and I will store it in an array. Now, you might notice that I'm not allocating memory using the getMem command or using a pointer. I'm just using a simple array. And you probably thought that this wouldn't work because every piece of documentation or example usage you saw of this always involved allocating memory using the get image size first to determine the amount of memory, and then allocating the memory, displaying the image, and finally freeing the memory. But you can also use a simple array, and that's what I'm doing right here. I know that the image I'm grabbing is going to use exactly 70 bytes, so I have an array declared up to 70 bytes. And I'm supplying it here, and I will use this command to convert that part of the screen to a mouse image. So I'm going to replace this M3 to T image, our temporary image, and everything else stays the same. And I will save this and switch back to Turbo Pascal. All right. So this should be our updated version. And let's try compiling it. Yeah, I got it first try. All right, so let's take a look here. And if I hit enter, we change the mouse image to the one I exported before. If we hit enter again, uh, okay. Let's try that again. All right, I think we got it this time. All right, our exported image, and now, so I printed the letter N on the top corner here. I grabbed the image and stored it into array, and then I converted it to a mouse image. So that's why you see I can move that N around. So basically, if you're using this CGA mode, you can do the same thing with any part of the image as long as it's 16 by 16 pixels. So I hope I've shown you something new today. So that's it for today. Thanks for watching.